Hello everyone, I'm Nex, and welcome to the solutions of the mini-test of our lesson 3 linear equations, inequalities, and absolute values. So our first problem, we had 3x minus 2 plus 4 equals to 2x plus 7. So first we solve the brackets. We get 3x minus 6 plus 4 equals to 2x plus 7. We subtract 2x on both sides. We get x minus 2 equals 7. I've colored with orange to see what I get from each part. So if we take minus 6 plus 4, we get minus 2. So we can do multiple steps at the same time without getting too confused. Then I add 2 on both sides, and we get 9, which is x is 9. However, we could also solve this in a bit of a different way. We could, at this point, so 2 steps ago, take away or add more stuff. So we would take away 2x on both sides and add 6 and take away 4. That way we do just one action and move all the variables to one side and all the numbers to the other. It's a bit more complex, more advanced. You can still take it one step at a time, but once you get far enough, once you know enough, you can do this way as well. Then we just add together these two, we get plus 2. 7 plus 2 is 9. Problem solved. For the second problem, we can solve the brackets one by one, each in a separate step. So we would first solve the first one and copy the rest of it. And then in the next line, we would solve the second one and would copy the rest. And in the third line, we would solve the third one and copy the rest. And after that, we would solve it all. But I'm just gonna go one by one in the same line, so you can see it without taking up too much space. So we have to solve all the brackets. First, we break apart this, so we get 2x plus 10. Then we get minus 3x plus 6, because minus times minus is plus, which equals to 4, we copy. And then minus, let's look at this as a minus 1 times the bracket with x plus 1 in it. So minus 1 times x is minus x, and minus 1 times plus 1 is minus 1. And now to move all x's to the left, we have to add x on both sides to get rid of it on the right side. And to get rid of the numbers on the left side, we subtract 16, as 10 plus 6 is 16. We get all the numbers on the right, minus 16 here, plus x here. And then I color all the blue ones so you can see which part goes where. So everything seems to be correct. After that, we just add them together. So 2x minus 3x plus x is 0, and 4 minus 1 minus 16 is minus 13. And since 0 does not equal to minus 13, the second problem has no solution, aka there is no x, there's no value for x that would satisfy this equation. Whatever you put in it as x will not be correct. So there is no solution, that's just the answer. For the problem number 3, we have to answer with an interval. So our problem is 4x minus 7 must be less than or equal to 2 times brackets 2x plus 1 minus 9. Now, first I will solve the brackets, giving us 4x plus 2 that comes out of them, leaving the rest the same. Now I subtract 4x on both sides and add 7. With subtraction of 4x, we remove 4x from the right, move it to the left. And with addition of 7, we move 7 from the left to the right. So 4x minus 4x is 0, which is less than or equal to 2 minus 9 plus 7. Now, minus 9 plus 7 is minus 2. 2 minus 2 is 0. We get 0 is less than or equal to 0. Since this inequality / equality equation is correct for any x, meaning that 0 is less than or equal to 0, any value we put in as x, this inequality would be correct. Would stand. So if I put in 0, if I put in 1, if I put in 2, if I put in 10,985, it will always give us 0 is less than or equal to 0. So it's true for all numbers, and the interval writing is x is an element of the interval of minus infinity to infinity, which is the final solution and the correct answer if you want the interval form for it. Now for problem number 4, we have 2x minus 5 under the absolute value is 21. Now we have to solve for these two conditions, so I'm just gonna do this at the same time. First, we just copy it the same as it was because it's greater than 0, so there is no need to change the sign in front of it. So 2x minus 5 is 21. And the second equation we have to solve is minus 2x plus 5 is 21. On the first equation, we add 5 to remove this negative 5 on the left side. And in the second equation, we subtract 5 on both sides, so we can remove the numbers from the left and give them to the right. Now, in the first equation, we just add these two together, we get 26, so 2x is 26. And on the second one, we get minus 2x equals to 16. Now we divide both sides by 2 on the first equation, giving us first solution, x is 13. And in the second equation, we divide by minus 2, giving us x is minus 8. There is also another way you could write this, especially if you're writing in a notebook. It's more space efficient. You copy the equation, put the equal sign and an arrow, so equal sign and greater than, then the squiggly brackets, and then above it, you just type in the first equation. So if the expression inside the absolute value is greater than or equal to 0, so you just copy it and then solve for x. And in the lower row or higher, it doesn't matter what the order is, you do the other way around. As we saw in the lesson, having minus 1 multiplied by the right side or everything outside the absolute value is also another way of solving the absolute values when the expression inside is less than 0. But as I said, I rather multiply the expression inside with negative 1 because it can get complex. But yes, this is the way to write it out as well. X is 13, x is minus 8, which gives us x1 is 13, x2 is minus 8. Now for the fifth problem, which we also have to solve with an interval answer, and I'm also gonna do it both examples at the same time. We have 3x plus 2 under the absolute value, which is lesser than or equal to 2x plus 5. We write down the conditions, and we solve. If it's greater than or equal to 0, we just copy the entire inequality down without the absolute signs. And for the second one, we just multiplied what was inside it with minus 1. Now, on the first equation, we move x to the left by subtracting with 2x, and we subtract by 2. So we get 3x minus 2x is x, and 5 minus 2 is 3. So x has to be less than or equal to 3. And on the second equation, we subtract with 2x, and we add 2 to move 2x to the left and 2 to the right. So we get minus 3x minus 2x, which is minus 5x, and we get 5 plus 2 is 7. So minus 5x is less than or equal to 7. We can still divide it by minus 5, which turns the sign around and gives us a fraction, which is x is greater than or equal to minus 7/5. Now, I can approximate this to minus 1.5. The exact value is minus 1.4, but approximation between 1 or 2 is good enough because we need to know the numbers relation compared to the other interval. For instance, if this was 7/5, any approximation between 1 and 2 would be fine enough, because we would have to just know that it's less than or equal to 3 for the point of the interval, because now the interval takes the form of this. Because x is less than, we take the intersection. So the intersection is between the lower of the two and the higher of the two. Since one of them is the bottom value and the other one is the top value, we go between these two. Anyway, we just see that one of the intervals is less than or equal to 3 and the other one is greater than or equal to minus 1.4. So we just take the minus 1.4 as the bottom value, close it because, well, we have the inequality sign with the equal part. The sign also means sort of equal. Hopefully you remember that. And so it is the same sign as, and the same sign also appears here, which means this is the correct answer in the interval form. Hopefully the mini test was successful. Hopefully you learned something. If not, that's also okay. You can go check back to my video. You can also look at other sources to learn more. Thank you so much and see you in the next video. Bye!